Hi, good day everyone. I'm Jake Albia, a faculty member from the Mathematics Department, and welcome to our new mathematics lesson. Today, we're going to explore the concept of radicals and rational exponents. Let's get started with it. For the lesson objectives, at the end of this lesson, you will be able to simplify expressions involving rational exponents, express a radical expression in terms of rational exponents, and vice versa, and simplify radical expression using the laws of radicals. We first need to define the nth root of a number. Let n be a positive integer greater than or equal to 2, and a raised to n is equal to b, then a is called an nth root of b. For example, if a square is equal to b, then a is a square root of b, and b is called a perfect square. If a cube is equal to b, then a is a cube root of b, and b is called a perfect cube. For example, since 3 square is equal to 9, and also negative 3 square is 9, and so both 3 and negative 3 are square roots of 9. Also, 9 is a perfect square. Since there may be more than one nth root of a number, we will define now the principal nth root of a number. Let b be a real number that has at least one real nth root. The principal nth root of b is the real nth root that has same sign as b and is denoted by a radical symbol. This is a radical expression where n is the index and b is the radicand. And this is the radical sign. Example. Since 3 square is equal to 9 and negative 3 square is equal to 9, and both 3 and negative 3 are square roots of 9, but only 3 is the principal square root of 9, that is, square root of 9 is equal to 3. Since negative 2 cube is equal to negative 8, so the principal nth root of negative 8 is negative 2. Since they have the same sign, negative sign, and for the number 1, if we will pick the positive square root, since 9 is positive, for number 3, the square root of negative 8 does not exist. This is true when n is even and b is negative. We will now define rational exponents in terms of radical expressions and vice versa. For any positive integers m and n, and any real number b for which the nth root of b exists, we define b raised to 1 over n be equal to the nth root of b. Also, b raised to 1 over n to the power of n is equal to this expression, which is the nth root of b raised to the power of n, which is equal to b. B raised to the power m over n is equal to b raised to 1 over n to the power of m is also equal to b raised to m to the power of 1 over n. So in terms of radical expression, this is the definition of b raised to m over n. For negative exponent, b raised to the negative m over n is equal to 1 over b to the m over n, which is equal to 1 over the nth root of b raised to m, where b is not equal to 0. Also, take note that 0 to 1 over n is equal to the nth root of 0 is always 0. Okay, so this is the exponential. We can convert from exponential form to radical form and vice versa. So for exponential form, b to the m over n, the m here is the power or exponent, and n is the index. Example, using the definition of rational exponents, we will apply them to compute the following. Negative 8 raised to 2/3 is equal to, by definition, this is equal to the cube root of negative 2 raised to the power of 2, which is also equal to the cube root of the negative 2 cube raised to the power of 2, but the cube root of negative 8 is negative 2, so negative 2 squared is 4. In another way, we can also compute negative 8 raised to 2/3. By definition, this is equal to cube root of the radicand negative 8 raised to square, which is equal to the cube root of 64, which is equal to cube root of 4 cube, which is 4. For 16 raised to the power of 3 halves, by definition, this is equal to 16 to raised to 1 half to the power of 3. But 16 raised to the 1 half is square root of 16 cube, but square root of 16 is 4, so 4 cube is 64. For 8 raised to the power of 2/3, by definition, this is the cube root of 8 raised to the power of 2, but the cube root of 8 is 2, so 2 square is 4. If you have a negative exponent, for example, negative 32 raised to negative 3 over 5, this is equal to 1 over 32 raised to 3 over 5. So by definition, this rational exponent is equivalent to fifth root of 32 raised to the power of 3, but 32 is equal to 2 to the fifth. So therefore, this is equal to 1 over 2 cube, which is equal to 1 over 8. These are properties of rational exponents. For property 1, the product of powers, the a to the m times e to the n is just equal to a to the m plus n. Example, if you have x to the 1 half times x to the 3 halves is equal to x to the 1 half plus 3 halves, which is equal to 4 over 2, equal to x squared. For the second property, power of a power, if we have a raised to the m raised to the n power is equal to a to the m times n. For example, 4 to the raised to 3 halves raised to 2, just multiply 3 halves and 2, which is equal to 3. So 4 cubed is equal to 64. For the power of a product, the quantity a times b raised to m is equal to a to the m times b to the n. Example, x y to the 2/3 raised to 1 half is just equal to, just multiply 1 half to each of the exponent of x and y. So x to the 1 half times y to the 2/3 times 1 half, which is x to the 1 half and times x to the 1/3. Number 4, quotient of a powers, a to the m over a to the n is equal to a to the m minus n, where a is not equal to 0. For example, if we have 3 to the 5 over 2 raised to 3 raised to 1 half is equal to 3 5 over 2 minus 1 half, which is equal to 2. So therefore 3 squared is 9. For the power of a quotient, the quantity a over b raised to the power of m is just equal to a to the m over b to the m, where b is not equal to 0. And this is the example, 27 over 64 raised to 1/3. So the cube root of 27 over cube root of 64, which is equal to 3 over 4. If we have a negative exponent, the a to the negative m is just equal to 1 over a to the m, where a is not equal to 0. So this is the example, 36 raised to the negative 1 half is equal to 1 over 36 raised to the 1 half is equal to 1 over square root of 36, which is 6. So therefore 1 over 6. If we have 0 exponent, this is, if a is not equal to 0, any a is equal to, not equal to 0, raised to the power of 0 is just 1. For your exercise, try to simplify the following expression by removing the negative and 0 exponents. That's it for our lesson on radicals and rational exponents. Thank you for listening, and I will see you in our next lesson.